What's up, team? Back again with another video. Pretty excited. We're gonna get down to the nitty gritty here with the Arduinos. So, what is an Arduino? I kind of went over this. It's just like a tiny little cheap computer that will do one thing really fast, and it's meant to kind of create autonomous devices. Now, it's very cheap. It's very customizable. The average Joe can go out and get this board is probably like 20 bucks. You can get them for even cheaper depending on the make and model. We're getting kind of the name brand for our classroom, but you can get them really, really cheap little Arduino boards. They make different kinds of boards, different sizes. For like drones and stuff that are really small, you'll use like Arduino Nanos. They make smaller, more compact versions. This is the Arduino Uno. It's like the cheapest, most vanilla kind of model that you can get, but very, very diverse. You can do a lot with it. Yeah, so it's a little tiny computer that takes information in and then, or takes, information in and then does that to control some circuits. Well, it's also called a microcontroller. Okay, we're going to go over the various parts and pieces of this today, so you guys will get a chance to kind of understand what's going on. I also want to say we're going to kind of ease into this. I don't want to jump into something really hard. I want you guys to ease in, be comfortable with using the board. Everything that you do in this lesson, you would be able to take directly to an actual Arduino board and make it happen. You can get a kit, like starter kits with all sorts of stuff in them for like 40 bucks. And we're talking like, boom, you got like everything you can imagine. Comes with resistors and everything that you need. So really cool little thing to mess around with. All right, we're gonna get going here. All right, so first thing we're gonna remember, we already went over this a little bit. Digital information is like a light switch, right? It's like 1, 0, 0, 1, on, off. But on an Arduino, we don't use the word on or off. We use high or low. And I kind of have these flip-flopped. That's kind of weird. I would say that 1 is on and 0 is off. I don't know why I have it that way. But high means on and low means off. Okay, so two different colors. This should be 1, this should be 0. So 1 is on, 0 is off. You might also hear this called discrete signals, but this is what digital information it looks like. It's either on or off, example being a regular old light switch. Analog information is like a dimmer switch or the brightness on your cell phone or temperature. It's got a sliding scale, exists on a continuous scale, and it turns out that you can do and manage both digital information and analog information with a digital device. It's somewhat analog information or somewhat analog circuitry. We'll go over that analog in more detail in a different lesson, but I want you to know that you can do both, and I'm going to show you where on your Arduino and where you can access that information. So all an Arduino is basically a bunch of circuits. It's just a bunch of little circuits that you can turn on or off. And I know that sounds like just digital information. It sounds like just a switch, right? Yeah, it's got a bunch of other capabilities as well. So the positive sides of the circuit, I'm going to go over that first. Let's change my color to red. All right, the positive sides of the circuit are, this is a positive port, this little 3.3 volts. The little 5-volt pin is also positive. And in terms of looking at the circuit, we view all of these as also positive. Okay? So this is the positive side of the circuit. This one, these ones, the 3.3 volt and the 5 volt, they are kind of always on. Okay, but these over here, we can control. We control the numbered ports. Okay, so we can turn these on or off. And you notice some of them have little squigglies next to them, little tildes, little wiggles, whatever you want to call them. We're going to go over what that means too. So these are the ones that we can turn on and off. The reason this is different than the robots, when we were dealing with robots, it's like we plugged in a specific device, the robot automatically registered what that device was and handled it accordingly. The Arduino doesn't do that. It just deals with circuits. It's just dealing with voltages, and then we can deal with those voltages and read them accordingly, but we have to do stuff with the voltages. We're having to do most of the hard work, or most of the processing of that voltage. So when these turn on, they are all turning on at 5 volts. Okay, so when these are on, they're all the way on, they're at 5 volts. Just like this pin right here. But this one, these two we can't control. So where they go off, the circuit's gonna leave these pins, it's gonna go off, it's gonna do something, and then it's gonna come back and it needs to return to ground. So there are 3 locations that the circuit can return to. So these ones are viewed as the negative side of the circuit. This one is negative, and this one is negative. So any circuit that leaves this board from any of these ports is going to have to return to one of these 3 ports here. You dig? Okay, that's pretty simple. G and D stands for ground, and it's viewed as the negative side of the circuit or the end of the circuit. Okay, so what are the differences between the ports on this side and the ports on this side? These are the analog ports, and they are for analog read. So this is for reading analog information. That means it can read a voltage that is basically that is different than just 0 or just 5 volts. Okay, so you can read a voltage with these pins with digital read, but you can only read it'll only read basically 0 or 5. These can read a range of different values for voltages. So it can read anything between 0 and 5. All right, and then all the numbered ports over here, we typically will use as like to write. So write really means it's an output, right? We're sending something, and read really means input. And it's so if you're sending digital, you're sending 5 volts out is what digital write means. Okay, digital read means you're reading 5 volts in. Analog write means you can send out anything basically between 0 and 5 volts. That's out, right? Anything between 0 and 5 volts. So that's 5 volts. This is 5 volts is what digital kind of means. There's on or off. This is our on or off. And this is our range between 0 and 5 volts. Okay, so the analog write, we're not going to do anything analog today, and we're not going to do digital read today. We're only going to focus on this one today. This is the one that we're going to be concerned with. But analog write, you can only do this in the ports that have that little tilde. Okay, and we're going to go over what that means. It says right there, PWM, in a later lesson. So analog write only happens in the ones with little tildes. Digital read can happen in any of them, and digital write can happen in any of them, but only analog is where it gets a little weird. Okay? Okay, here we go. Oh, yeah, sorry. These ones are called I/O. These ones are just input pins. Okay, it says analog in. These ones are called I/O pins. The reason they're called I/O pins, I/O stands for input output. So if you're watching a YouTube video or something on an Arduino video, they say, I'm gonna go to the I/O pin, trying to be like cool and trendy. Not necessarily helpful for people that don't know what that means. It just means input, output. Okay, so when we're programming an Arduino, it's very, very similar to programming a robot. We have our preamble in the program, and then we have this thing called a setup. And what the setup does is this is where you indicate, basically in setup, the only function I really have ever used is pin mode. But basically what you're doing is you're saying which ports, so this is our port number. Okay, what port are you using and how are you using it? We're using port 13 as an output, meaning we're going to be sending information out. Okay, so that means we're writing information. These are the parameters that go into pin mode, And that's pretty simple. If you're using more than one port, which you will in your assignment, so you need to be careful. If you can't get your program to work, it's because you haven't set this up correctly, okay? If you're using more than one port, you need to state each port that's being used in the void setup, okay? The preamble for the program will be up here, above void setup, and after void setup comes void loop. Now, with an Arduino, this is different than the robot. With the robot, when we ran the program, it did sequential execution, doop, 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 doop. It would go through and do everything in a row, and when it got down to the bottom, the program was over and your robot would stop. Okay? That was it. It would exit the program. An Arduino never exits. So essentially, do you remember how we had to always put like while true inside our robot program to get it to go forever? This is essentially what the void loop is. The void loop is just a while loop that happens over and over and over again. So this Arduino will repeat the program over and over and over and over and over again. So let's go over what our program does. And I'm gonna make sure we've got a good view of, so you guys can see. I'm gonna drag these over a smidge. Okay, let's go back to the big screen. All right, so in void loop, void setup is where we choose what our pins are going to do. And in void loop, this is what our Arduino does. So this is what the Arduino does. Setup is where we teach it things. Preamble is where we teach it other things. The loop is where this is the stuff that it does. So what we're telling our Arduino to do is digital means we're going to digital write. We're going to send basically 5 volts out of port 13 because it says high. High means on, and on means 5 volts, okay? So we're sending 5 volts out of port 13, just like, you know, this is just like what we had with the batteries. We were using 4.5 volts, but like on the Arduino, this 5 volt pin here, where's it? 5 volt pin right there. We can use just like that 5 volt pin. You can use that 5 volt pin just like a battery, basically. Just like when you have your Arduino plugged in, it just acts like a battery. All right. So, but this is doing the same thing, but this is a battery that we can shut on and off. Okay. So digital write, port 13 onto high, and then we delay. This is the same as wait for the robots. And what this means is it's not going to move. It's going to stay on this line, basically. Stay on this line for 1,000 milliseconds. It's the same as the wait 1 msec from Robot C. Okay, and then what this says is we're going to digital write port 13 onto low. A lot of people think that when the program runs, like if I just ran a program that said digital write high, delay 1 millisecond, if I just ran that program, the light would turn on when you start the Arduino, and it would never turn off, right? We have to manually turn the light off or turn the port off, cut the 5 volts to the circuit. And the way that we do that is with low. This means off. So we're cutting 5 volts essentially there, okay? And then we delay again. So let's recap what our program does. It sends 5 volts through the circuit. So it turns it on, and then it doesn't do anything for a second, and then it turns it off, and then it doesn't do anything for a second. So the light should blink. Okay, this is called your basic blink program. That's basically it. Okay, remember for comments, we will use // if we want to comment something out in our program. We're going to go ahead and build a basic circuit here in Tinkercad. If you want to purchase an Arduino, the IDE, which stands for Integrated Development Environment, is completely free to use. You can program in browser. You can also program and just download the program, and it's super easy to install. If you want help doing that, I'd be happy to do that. If you want to order up an Arduino or something, that's an option. Okay, yeah, so let's go to Tinkercad and let's drag in the Arduino. And yes, Tinkercad has Arduinos built in, which is awesome. Okay, full screen. Let's get it so we got a good view. Yeah. Nice. Come on, man. What are you doing? There. Okay, perfect. All right, let's open up our menus here. We're going to create a simple circuit. We're going to grab in a resistor. I'm going to grab an LED. I'm going to show a couple ways that we can do this. So if you want to just light an LED like a battery, we'll use 5 volts and ground. I'm going to show you a couple different ways people use Arduinos, just so you know. You do not have to use these power rails. I'm going to do it with the power rails in just a second because that's what you'll see on the website. If you look at the Arduino book, I have uploaded an Arduino textbook that has tons of circuits. So if you're like, Slagle, this is too easy, man, I want to move ahead and do something that's harder, go ahead and look at that. And then you can try and make some other circuits with what's on there if you want. So work ahead. If you're feeling up to it, go ahead and go for it. All right, so what we're going to do here, that's the negative side of my circuit. So what I'm going to do is I'm going to have that come out, and I'm going to send that to ground. I'm going to try and make this nice and 90 degrees. Let's drag that up a smidge, nice and rectangular. Ground is my black side. You don't have to color the wires if you don't want to. You can choose any port you want. Port 9 is fine. I'm going to come out this direction. Okay, now if I turn this baby on, making that my red side, you guys probably already see the problem with my circuit. If I start simulation, the light doesn't turn on. Well, it's because we didn't tell it to turn on. We have to go into our code. Now, some of you may have blocks. Okay, you want to click this drop-down menu and go to text. So we have to write our code here. Back it up. We're going to say pin mode port 13, and we want that as an output. Okay, that's the first step. And we're going to do that blink program, which, let me just write it really fast. It shouldn't take too long. Oh, where's my tab? Where's my tab at? Oh, that's weird. All right, so then we're going to say digital write. And we're going to do, we're not using port 13, excuse me. We are using port 9. So you have to choose whatever port you have as their positive side. So I'm using port 9. We're going to digital write port 9, and we're going to turn that on to high. All capitals. If you don't use capitals, it's not going to work. We're going to add a delay of 1 millisecond. Or sorry, 1 second, or 1,000 milliseconds. I'm just going to go ahead and copy and paste that down and add low. Turn port line on low. So let's go ahead and run our simulation now. Oh, look, it's looking good. We got 5 volts going to the light bulb, but it's saying, hey, this is operating at not a great level for the light. It's going to burn out if we let it run like this. So it's on for a second, off for a second, on for a second, off for a second. I'm going to tell you right now, this is not nearly as satisfying as actually doing it with an Arduino, but you know, it gets the job done here. So we need to add a resistor somewhere in this circuit. So there's a couple ways that we can do that. I'm going to show you a couple little different ways to view the breadboard. I'm going to close the code for now. One way is to use the second row here. So you can add a resistor anywhere. So if we're using 5 volts, we might need to do Ohm's law. 5 divided by, doesn't matter the direction. Let's say 5 divided by, also doesn't matter which side. 15 milliamps for 0.015. We want a resistor that is, I think, 5 divided by 0.015. 330 ohms. So we're going to click on our resistor. We're going to click on our resistor. Oh boy. Where's this thing? It's wigging out here. Well, let me change the, oh, there we go. Resistance, 330. We want that ohms. All right, and this is what comes in our kit, and then we can connect here. We've now provided the appropriate amount of resistance for our light bulb, so it's not going to be damaged, and we have 5 volts coming out. So you got to know that these are 5 volts in order to prepare for that. So that's one way to do it. Now here, we just use these rows together. We have the resistors sitting in the middle. If you like that method, great. That's not how you're going to see it in the book. This is how they do it in the book, and this is a little strange, but I want to show this to you as well. So let's go like, I'll just delete these and restart. So for the book, we have that going to the positive side. Doesn't matter where you are necessarily. Up here, turning, and down there. I nailed that. Absolutely nailed that. Green, change that to black. So in the book, they're going to charge the power rails up, and you can put the LED wherever you want. And then what they do is they send the negative side back to ground. And then actually they have the positive. I think they have it like this. They'll have a wire coming out of 5 volts, which is completely unnecessary. It's actually unused, but you'll see a lot of circuits start like this. This is supposed to represent the positive side of the circuit, but it ends up getting unused. And then what they do is they run, they run the port. I've already screwed this up, just a sec. They'll run the port up to where the Arduino row is. So they'll run positive to the right side of the Arduino, and then they'll grab press this arrow, they'll grab that resistor, 330 ohm resistor, and drag that in. Except that needs to be returned to negative. Okay, and then we'll color this. This is the positive side of our circuit. This is the positive side of our circuit that is unused. This wire is completely unnecessary, but this is what's in the book. So I'm just following what's in the book. So, and I'll show you why it's unnecessary. We turn port 9 on. It runs up through the Arduino, down through the resistor, through the power rails, back to ground. At no point are we using accessing the 5 volts here. Now, if I were to stop the simulation, delete this wire, and run from here to here, well, this is just like using a battery. When I start simulation, the light's not going to blink. It's always going to be on because this is always on and it's not being controlled. You might be saying, hey, can you hook up port 9 to the positive rails like this and delete here? What's going to happen there? If I, oops, stop simulation, run positive to the light. Absolutely. Absolutely. You are branching, you have your circuit here and you have this parallel branch coming off. The problem is that this positive rail is getting turned on and off, so there is no way for something to be always on inside this circuit. So if you want to control something individually, typically you want these power rails to be always on, and then anything that you want to control individually goes directly to the port. So I can click there, delete out, run the simulation, and it will turn that on. So let's go back to our code really fast and get you started on what you're going to be doing for the for your assignment. You're going to be controlling the speed here. If you want to get fancy, you can create a variable in the preamble of your program that controls the speed of the blink. That's something that you can do, and you could make that an integer, which would be a good thing to do. So you could say like int wait time or int whatever, and then put that variable down here and in the place of 1000. Control the speed for all the blinks simultaneously. Okay. Yeah, that's all I've got for you. I want to ease into controlling these Arduinos because it kind of ramps up pretty fast, and I want to make sure everyone's understanding everything. So yeah, thanks for watching, and I hope y'all are having a fun break. We'll see you in class. Bye.